everyone. This video would focus on conic section, specifically on ellipse with center at 0, 0 or at the point of origin. And this is the 7th part. In this part, we are given the two endpoints of the minor axis and the two endpoints of the major axis in our problem. And we're supposed to determine the standard equation of an ellipse given these two information right here. But before we go over this example right here, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the endpoint of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex. And we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that again, our A is always greater than B. Now to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now let's go back to the problem. Okay, we go over the problem here. So we're supposed to determine the standard equation of an ellipse given these two right here. The two endpoints of the minor axis are these two, and these are the coordinates of the endpoints of the major axis. So we are going to plot these four points right here. Okay, looking at these dots right here, we need to determine which of these dots would be considered the co-vertices and which are the vertices. So we start with this given right here. We say that the endpoints of the minor axis. Now we remember that the two endpoints of the minor axis are the two co-vertices. So in this case right here, these two are our co-vertices. I'm going to label this as co-vertex, and this is the other co-vertex. Well, on the other hand, the endpoints of the major axis would be the two vertices. So in this case right here, this will be our first vertex and this is the other vertex. Now, looking at this, we remember that the center of an ellipse is the midpoint between the two vertices or the midpoint between the two co-vertices. So we can use the midpoint formula to determine the center between these two co-vertices, or we can use the midpoint formula to determine the center of these two vertices. However, we can determine the center between these two vertices or between these two co-vertices by eyeballing it. And so we can go ahead and say that the very center here is at 0, 0. So this will be our center. Now, looking at this problem further, we can see that this type of ellipse is a vertical ellipse because the major axis is the vertical line right here. So this line is longer than this line segment. So this is a vertical ellipse. So I'm going to write that information up here. Since the center of this ellipse is 0, 0, or at the point of origin, I'm going to write the general formula for the vertical ellipse with center at 0, 0 down here. Now, please notice that our value of A is again always bigger than the value of B. And since this is a vertical ellipse, I am putting the A squared at the bottom of the Y squared because again, this is a vertical ellipse. So we need to determine what is the value for B and what is the value for A. Now, looking at the figure that we have right here, we can say that our A value, we can count, remember, the A is the distance from the center to one of the two vertices. So in this case right here, we can just go ahead and count 1, 2, 3, 4, 5, 6. You can also use the distance formula between the center and the vertex. That would give us 6. So we can say that our A is plus minus 6. Again, our A is along the major axis. Now, we can therefore say that our A squared is actually 36. And then we go ahead and determine the B. The B is the distance from the center to the co-vertex. So just by counting it, 1, 2, 3. So that would be plus minus 3. And then we can also use the distance formula. You can determine the distance from the center to the co-vertex. It will still give us 3. And so we can go ahead and say that our B squared is 9. So what we do is we plug these values into the A squared and B squared right here, these 36 and 9 respectively. And so we are able to get the equation. Okay, so this is the equation for this problem right here. And so we can go ahead and sketch the ellipse here. Okay, now we are supposed to determine the location of the focus. Now we remember that the distance from the center to the focus is represented as letter C, and we can use the equation C squared equals A squared minus B squared to solve for C. And so we plug the values in. So we have C squared equals, that's gonna be our A squared is 36 minus the B squared is 9. And so we got C squared is equal to 36 minus 9 is 25. So we are going to square root both sides. So I'm going to square root this. I'm going to square root that one as well. So we are able to get a C value of plus minus 5. This tells us that from the center going up 5 and from the center going down 5 is the location of the focus. So I can go ahead and say that we go 1, 2, 3, 4, 5. That's the first focus. And the second focus is 1, 2, 3, 4, 5. This is where the other focus is gonna sit. And so we can go ahead and write the coordinates of the two foci. So this is the equation for this problem right here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given the two endpoints of the minor axis and the two endpoints of the major axis, and we're supposed to determine the standard equation of this ellipse. So I'm going to plot the 4 points given in this problem on this graph that we have here. Okay, we remember that the endpoints of the minor axis would be our co-vertex. So this 0, 5 and our 0, negative 5 would be the co-vertices of this ellipse. While on the other hand, we remember that the endpoints of the major axis would be our vertex. So this will be the first vertex and this will be the other vertex. So these two. Okay, now we remember that the center of an ellipse is the midpoint between the two co-vertices or the midpoint between the two vertices. So in this problem right here, we can go ahead and eyeball it. We can just count it. So from here we go 1, 2, 3, 4, 5, 6, 7, 8. And so they meet at this very point right here. So we can go ahead and say that our center is at 0, 0. Now, the other option when you're not comfortable in eyeballing it and counting it, you can use the midpoint formula. So use the midpoint formula. We are still able to get that the center is at 0, 0. So I'm going to label this as letter C. Looking at this, our major axis is the horizontal line segment because this is longer from the center going to the vertex is longer than the distance or the length of the line segment from the center to the co-vertex. So this is an example of a horizontal ellipse. So I'm going to write the information up here. Okay, since this is an example of a horizontal ellipse, I am going to write the general formula for a horizontal ellipse down here. Okay, notice that our a squared is under the x squared because again, this is a horizontal ellipse. So then we need to determine the value for a and the value for b so that we are able to write the equation of this ellipse. So let's start with letter A. Now we remember that we can determine the distance from the center to the vertex by using the distance formula, and that is our a. But we can go ahead and count it. 1, 2, 3, 4, 5, 6, 7, 8. Either way, you use the distance formula or the just by counting it, you still get the same answer. So our a is plus minus 8. Now, to determine the b, we go ahead and count the distance or determine the distance from the center to the co-vertex. Again, there are two ways to do this. You can use the distance formula that is from 0, 0 to 0, negative 5. You can do that, or you can count it. So that would be 1, 2, 3, 4, 5. So our b is plus minus 5. So this tells us that our a squared is 64, b squared is 25. So that we can go ahead and plug these values in here so we are able to get the equation of this ellipse. Okay, now let's determine the location of the two foci. They should be located along the horizontal line. Now we remember that the distance from the focus to the center is represented as letter C, and we can solve it using the formula C squared equals A squared minus B squared. And so I'm going to show the work down here. So the value for C, which is again the distance from the center to the focus, is plus minus square root of 39, or that is approximately 6.24. So from here, I go count 6.24. So 5, 6, and then 0.24 should be somewhere around here. So this is our first focus. And then the other focus would be across. So that's 6, 6.24. So that should be the other focus right here. So that we can go ahead and sketch the graph of the ellipse and determine the coordinates of these two foci. So this is the equation of this problem that we have right here, and this is the graph of this equation. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!